Hey y'all. Today's objective is the greatest integer function. And the greatest integer function, otherwise known as the step function or the floor function. The step function, you'll see in a minute what's called the step function. The floor function is just kind of, some people call it that because it helps remind them of exactly what it is. This is the notation. F of x equals these brackets. The greatest integer function, otherwise you'll hear me call it the step function because that's what I like to call it. Some people will refer to it as the floor function. It takes the input and finds the greatest integer closest to that number without going over. Otherwise, think about The Price is Right. So if you've ever seen The Price is Right, you have to guess the price without going over. So this function takes a number, the input, and it finds the closest integer, the greatest integer, without going over. So I'm going to give you some examples. And you have these notes that we're going through together. So you'll see the blanks, and you're going to be filling in the blanks. Takes the input and finds the greatest integer closest to that number without going over. All right? So examples, here we go. If you had 7.35, notice how it's in brackets. When it's in brackets, that's how you know we're talking about the step function. The greatest integer without going over, so it is 7. It's the greatest integer, and it doesn't, well, you can't use 8 because it doesn't go over 8. So it takes that input and finds the greatest integer closest to that without going over it. So how do I explain that? That's why some people call it the floor function. My phone is beeping. The floor function means it's like the floor of that number. So 7.35, it would be the floor, and it's closest to 7, because you can't go to 8 until you've already gone over it. So it's the integer that's closest to that without going over. So you can't go over it. So the answer is 7. 4/3. Really, if you think about 4/3, that is 1 1/3. So if you need to rewrite it as a fraction, 1 1/3. So the closest integer without going over is 1. You can't go up to 2 because then you've gone over this value. You can't go down because you want to get the closest integer. So that's why some people call it the floor function. Negative 2.5. So your mind, you should be thinking, okay, well, it's either going to be negative 2 or negative 3. So again, it's the greatest integer without going over. Now, we've gone over negative 2, but we haven't quite gotten to negative 3. And so whenever you have these, you have to think, it's weird, the negatives are weird. So this answer would be negative 2. Negative 3, sorry. Because we have gone, how do I explain this? In the negatives, it's gone past negative 1 and it's gone past negative 2. So it's gone, I'm trying to think about the best way to explain it. So it's the greatest integer, it's the floor function. So if you're going negatives, it's opposite. So it's like you've gone over, we're reversed. So we've gone over negative 2. We haven't gotten enough to get to negative 2. I know I'm going to have questions about that. Negative 10 over 5, this is negative 2. And so it's the greatest integer without going over, but it can be exactly that integer. So this one's going to be a little confusing. But let me show you how to graph. The nickname is called the step function. So here's our parent function. And to graph the step function, I'm going to show you by using a table of values. On your paper, you have a table of values, and they start at negative 2, and then they increase by 25 hundredths, I believe. And I've already filled in the values. So if we're talking about the greatest integer closest to that value without going over, the greatest integer would be, for negative 2, it's negative 2, and then for the negative ones between negative 1 and 2, it would be negative 2 because it hasn't gotten to that higher number yet. It's always, looking to that higher number. And the negatives, it's just weird because it's backwards. Kind of like this one wasn't 8 because it's gone over 8. We haven't gotten to 8 yet. Just like this one can't be negative 2 because when you're going backwards, we haven't gotten to negative 2 yet. Maybe that will help. So from here to here, it's negative 2. But then once you get to negative 1, it's equal to negative 1, and these values will be negative 1 because that's the closest integer but hasn't gone over yet. Then you have the 0 group, then you have the 1 group, and then you have 2. Now, the values, it's just the greatest integer whole number, but without being more than it. So the positives should make sense. 125, 150, 175. It hasn't gone over 2, so that's why it's still, you're going to be in the 1s. This one hasn't gotten to 1 yet, so you're still going to be in the 0s. To graph it, if it's equal, like right here and right here, it's going to be a closed circle. And I'll show you what that means. So from negative 2 to negative 2, it's going to be a closed circle. And then we're going to have a horizontal line until we get here, until we get to negative 1. That's going to be open. From negative 1 to 0, we go up a step, and then it's going to be open circle. From 0 to 1, it's equal at 0, 0, so it's a closed circle, but then it's open right here. And then at 1, 1, it's a closed circle, but then it's open right here. And then you would keep that pattern, always the first one being closed and the second one being open. And this is why it's called a step function. This is a step function, the greatest integer function, and the floor function. Because whatever is in this bracket, you're going to go to the closest integer, but that integer can't be over that amount. And then here's what the graph looks like. Sometimes that circles are closed if it's equal, sometimes the circles are open. And you can't overlap because then it wouldn't pass the vertical line test. So if you have circles right on top of each other, one circle is going to have to be closed, one circle is going to have to be open. Otherwise, it would not pass the vertical line test. It would not be a function. So that was this whole first page. So transforming a step function. Here is the graphing form. Y equals A times B x minus h plus k. Your starting point is h and k. We've been dealing with this. We know that's going to be the opposite. So if it says minus h, we know it's going to be the opposite. And then you have k. Your step length, this is how long the steps are. It's going to be 1 over b. That's a b. 1 over b. So this value right here, if b is 1, then your step length is just going to be 1 unit. If b is 2, then your step length is going to be half a unit. If b is a half, then your step length would be 2 units long. So that's how long your step unit is. This space between vertically is a. So that's like your step height. So in the parent function, they were 1 unit long and they were 1 unit away from each other. But that's how you tell the step length and the step height. If A is positive, it's going to go up. If A is negative, it's going to go down to the right. So you'll see your steps increasing and you'll see your steps decreasing depending on what this A value is. So let's try a few examples, 2 examples I think. Alright, example 1, graph this function, 2, and then in your brackets, x minus 3 plus 1. So your starting point is right here, 3, 1. Notice I took the opposite like we've been doing. That means it's going to, because of this negative, it means it's going to shift right, and that's why we're going to start at 3, 1. Then your step length, remember this was 1 over b. B is 1, so my step length is just 1. Now my step height is 2. This is your A value, which means I'm going to skip 2 units in between my steps. Now let's graph it. The 3, 1 is my starting point, so I'll go over 3 and up 1. And there is my first step. Remember, the length was 1, so I went 1 unit, and I drew my first step. Let's see, over 3, up 1. Then I need to go up 2. So 1, 2. And here's my next step, and I'm going to go down 2. 1, 2, down 2, down 2. So that is how you would transform a step function. It looks similar to the parent function. You kind of think of it as a vertical stretch. That's what we talked about. That means I've stretched it out. Instead of 1 unit, I've stretched it out 2. My lengths are still 1. So if you notice, I went up 2 over 1, up 2 over 1, up 2 over 1. And it passes the vertical line test because my first dot is colored in and my second dot is open. And it all started at over 3, up 1. All right, so example 2. 2x plus 4 minus 5. We've practiced transforming. You have to you have to manipulate it into a form that we can see. So because of that, I'm going to factor out a 2. And then I get x plus 2. Now I have a form that I can easily see the transformations. If you leave it like this, then you're not going to be able to see everything quite as well. Once you change it into your graphing form, we can get our starting point. So our starting point is going to be -2, -5. My step length, I have a B now right here. So it's going to be 1 over 2, which is a half. That means it's going to be, each step is going to be only a half unit long, so they're going to look shorter. And then my A value right here is a 1, so my step height is going to be 1. Now I'm going to graph it starting at -2, -5. -2, 1, 2, 3, 4, 5. And I'm only going to go half a unit, so it's going to be really small. Then my next one, I can go over to that spot. I'm just going to go up 1 unit, and then I can go over. Then I go up 1 unit, and then I'm going to go up 1 unit, and then over. So you can see I've gone up, whoops, I messed up. I got to go up 1 unit, over, up 1 unit, and then over. So you can see I'm going up 1 unit each time, but my lengths are so little that I've only gone this space. I've gone 2 units in 4 steps. That's because I'm going a half a length each time. I'm not going 1 full length. So once I get here, I'm going to go up 1 unit and then over a half, and then up 1 unit and then over a half. Up 1 unit and then over a half. Up 1 unit and then over a half. So maybe you can see, and if you're doing this on your paper, you'll see that these little grids in the grid that you're going half a unit, like half a unit over, but you're going up 1 full unit. So we'll practice more with step functions, but very unique, very different, and but the graph is always going to look similar to the parent step function, and that you're going to have steps, and then they're going to be lengths and vertical